Hello viewers, I am Professor Jaya Shrivastava. In this video, I will discuss about textures of igneous rocks. Under this, I will discuss significance of texture and textural elements. Under the textural elements, the crystallinity or degree of crystallization, granularity or grain size, shape of the mineral grains, and phaneritic rocks, aphaneritic rocks, and lastly we will discuss a summary. First, I will show you granite and basalt specimens, how they look in hand specimens. Holocrystalline granite specimen, B is our hemicrystalline dolerite specimen, and third one is holohyaline basalt or rhyolite specimen. The same specimen is seen under the microscope. You can see on my left hand side granite, and right hand side you have a basalt slide under thin section under the microscope. There are minerals, they are seen quartz, biotite, plagioclase, K-feldspar seen under the granite slide, and plagioclase, agate or clinopyroxene seen under the basalt thin section. Now let us introduce what is fabric, a non-compositional property and defined as agreement, orientation and mutual relationship of mineral grains and glass. It includes textures and structures both. Texture also called microtextures. What is texture? Texture defined as glass versus mineral grain relationship, and it is based on glass versus proportion of mineral grains, their size, shape and mutual arrangement. What is the significance of texture? Texture and structures provide an idea of crystallization of the magma, physical chemistry of the magma, cooling history of an igneous rock. What are the textural elements? I have already told you: crystallinity or degree of crystallization, granularity, shape of the crystals, but the mutual relationship among crystal and non-crystalline matrix or glass we will discuss under the igneous rocks part 2. A. Crystallinity. Degree of crystallization is a ratio between crystallized and glassy matter. Modal percent of mineral grains relative to glass, it varies from 0 to 100%. Crystallinity related terms, for example, crystallites. Crystallites are those crystals or embryos of crystals of varied shape. Longulites, cylindrical rod-like crystals with rounded ends. Globulites are minute, spherical, opaque crystals consist of iron oxides. Globulites aligned like a string of beads in case of margarites. Scopulites is a needle shape with divergent plumes. Trichites are basically filamentous, hair-like crystal shape. Then microlites are larger bodies, minute crystals which are of needle shape. Glass is formed by supercooling of highly viscous silicate melt. Glass has disordered atomic structure. Let me show you rod-like microlites in the pitch stone in this thin section. The white colored rod-like plagioclase crystals appear as stellate clusters. They are basically rod-like microlites. Now, crystallinity based texture and inferences can be obtained from in the field also, from the outcrop, hemicrystalline, whether the rock is coarse grained, holocrystalline, hemicrystalline or hyalocrystalline. These observations can be made in the field. And on the basis of these observations, we can ascertain about the factors that control crystallinity of the rocks. The cooling rate shows slow cooling of the magma, large size crystals, whereas rapid cooling gives rise to finer grain size crystals. Depth of cooling and volume of the magma can also be assessed with the help of this grain size. Slow heat loss in deeper levels show slow cooling, whereas rapid heat loss at shallower depths show rapid cooling of basalt and glass. For example, composition and viscosity of the magma. High viscosity magma, basically they are siliceous lavas For example, rhyolite, they produce non-crystal glass, whereas less viscous mafic lavas produce ephiric basalt. High viscosity lava are highly volatile, whereas low viscosity lava are low volatiles. Then granularity, it varies from meter size to few centimeter to 0.01 millimeter size or glassy. Common terms which are used to describe grain size are pheneritic, which is used for coarse grained rocks, can be seen, and these rocks can be seen by the mineral grains can be seen by unaided eyes, and epheneretic or hyaline or glassy term is used when the rock is fine grained and it can be seen only under the microscope. Ferric and ephiric commonly used for basalt in a state of pheneritic and epheneretic. In case of basalt, we use ferric and ephiric. Now, pheneritic texture is subdivided into three main categories: equigranular, inequigranular, and pegmatitic. Equigranular, grains of equal size are present in this type of texture. Seriate texture is grain ranges more or less continuously in size. In case of inequigranular texture, there are two basic categories: porphyritic texture and picolitic and ophitic textures. In case of porphyritic texture, large grains or phenocryst embedded within fine grained ground mass. But in case of picolitic and ophitic texture, larger crystals called oikaicocrust enclose smaller grains. And third category is pegmatite texture, which is composed of large heterogeneous size crystals. Now I am showing you pheneritic and epheneretic rocks. On my left hand side, you have a pheneritic texture where you have a very coarse grained crystals of agate, plagioclase. They can be seen, big size crystals, but on the right hand side, you have a ephenetic texture where plagioclase crystal size is very small, and the similar slide is shown with the help of a hand sketches on the top. Second one slide here shown is pegmatite, showing coarse grained anhedral crystals. You can see the entire grain is covering almost 60-70% of the view of the slides in the sketch of a view in thin section. And on the left hand side, you have a big crystal in hand specimen that can be seen. Now, pheneritic rocks, that means large size crystals seen with unaided eyes, they can be pheneritic texture associated with magmatic intrusions. It reflects crystallization at low degree of undercooling and also low rate of nucleation. Nucleation rate is always low. Textures formed under plutonic conditions and emplaced on surface due to upliftment. Pheneritic rocks subgroups, they can be divided into 4 subgroups: fine grained or glassy. They are formed by rapid cooling. Example is basalt, rhyolite, obsidian, all volcanic rocks. Then medium grained, moderate cooling rate, dolerite, lamprophire, hyperbasal rocks in dikes and sills. Coarse grained rocks, very slow cooling rate, for example granite, cyanide, gabbro in case of plutonic rocks. Then next is very coarse grained rocks, extremely slow rate of cooling, for example pegmatite, large complex pegmatitic bodies. Here I have shown you all the 4 varieties: coarse grain, medium grain, fine and glassy texture in a megascopic view. No grains. In case of glassy, there is no grain which can be seen in thin section. Here I am showing the photomicrograph. Photomicrograph A, B and C show fine grained, medium grained and coarse grained textures. Slide A, you have plagioclase, clinopyroxene in slide B, and CPX, that is also called clinopyroxene, which is altered in some cases, and pelagonite. Pelagonite is an altered product of mafic minerals. Now, aphanitic rocks are those rocks where the crystal size is too small to be identified by hand lens. They can be subdivided into 2 subgroups: microcrystalline, grains visible only under the microscope, And cryptocrystallines, when only felty mass is visible but no mineral grains seen under the microscope. Here is the slide which is seen under the microscope. Texture A, microcrystalline on my left hand side, and B, felty texture is on my right hand side. Later in a slide, interspaces between the plagioclase laths are occupied by cryptocrystalline material or such as olivine, plagioclase, glass and clinopyroxene. Ephiric rocks ephiric texture is shown in this slide, where you have entire section consists of microcrystallites but no phenocryst. Now felty texture. Plagioclase microlites are large enough and interwoven in a felty texture as seen in basalts and andesites. Now factors controlling grain size such as cooling rate. Slow cooling favors large crystal growth, as I have told you earlier also, initiates crystallization centers, ionic diffusion causes large crystal growth. Then second important factor is viscosity. Viscous magma opposes ionic diffusion, thus hinders crystallization. It depends on H2O, CO2, H2S, chlorine, fluorine concentration and silica and alumina concentration as SiO4 and AlO4 units linked together as polymers and form dense networks. Fine grained glassy rocks such as rhyolite form from siliceous viscous magma. Molecular concentration and chemical activity: zircon, apatite, sphene, rutile, ilmenite form small grains as they are of low molality in the magma. And third important factor is complexity of magma composition. It increases with the rise in chemical components. Now third category is shape of the crystals. It is of three types basically: euhedral, subhedral and anhedral. Euhedral, when euhedral crystals are present in the rock or they are seen under the microscope, you call it as idiomorphic texture. For example, minate or lamprophire, panidiomorphic granular texture when majority of grains with euhedral faces, for example, pegmatite. All faces are well developed, euhedral, and example is pegmatite. Subhedral, when subhedral grains are present in the rock and seen under the microscope, the texture is called hypidiomorphic granular texture. For example, gabbro, granite called granular texture. Also it is called as granular texture. The third important category is anhedral. When all the grains are anhedral, the texture is called allotriomorphic granular texture, also called xenomorphic granular texture. For example, it is present in aplite, aplatic texture in hyperbasal rocks. All the three textures shown here with the help of sketches. A, panidiomorphic granular texture on the left hand side top of the screen, and below that you have a hypidiomorphic granular texture, and on right hand side you have allotriomorphic granular texture. In textures, mineral grains are grouped as equidimensional, prismatic, tabular, platy or sheet-like or irregular. Depending upon the shape, they have been grouped as equidimensional when grains equally developed along all the three faces or axes of the crystal, for example, garnet, olivine, lucite. Prismatic grains grow along C axis comparing to A and B axis. For example, agate, hornblende, grains with minor growth along A and B axis called axicular, for example, sanidine crystals. Tabular crystals, grains with greater growth in length as compared to width. Example is plagioclase and orthoclase. Platy or sheet-like grains grow along length and breadth in relation to height. For example, mica. Mica crystals are the best examples. Then last is irregular grains, grow irregularly in all dimensions. Best example is quartz irregularly in all the three directions. Now the factors that control shape of the grains: crystal habit controlled by lattice structure of a crystal, conditions of growth, crystallization conditions largely control grain dimensions, e.g. euhedral, elongated lathe shaped plagioclase in dolerite and basalt, subhedral or tabular in gabbro, and anhedral in case of granite and applied. Third one is important, is order of crystallization. Shape also guided by order of crystallization. Earlier formed crystals are well developed than later formed crystals. And lastly, slow cooling favors diffusion process, thus allow euhedral grains to form. Now, summary, we can summarize the entire discussion. Fabric, first I have defined the fabric. Fabric is defined as arrangement, orientation and mutual relationship of mineral grains and glass. Textural, what are the textural elements? Textural elements consist of crystallinity or degree of crystallization, B. granularity or grain size, shape of the mineral grains, and fourth, mutual relationship among crystals and non-crystalline matrix. Crystallinity is a ratio between crystallized and glassy matter. Granularity varies from meter to few centimeter to less than 0.01 millimeter size or microlites or glassy in case of volcanic rocks. The idiomorphic or panidiomorphic granular texture, hypidiomorphic granular texture and allotriomorphic or xenomorphic granular textures. All these textures, they depend upon the shape of the crystals. In the next session, we will discuss in detail about mutual relationship amongst crystal and non-crystalline matrix. Thank you.